A lot of things have been discussed on the basics of the nuclear chemistry. So I hope you have understood why nuclear chemistry is important and how many reactions are having nuclear basics and how many reactions are having the basis as chemical reaction was clearly understood from some of the previous videos I have put. That is, nuclear reactions are more in nature and important elements have been synthesized only on the nuclear basis front. So let us look into how these have been brought into picture. That is, we have got two processes. One is called as the nuclear fission, and I think another one is the nuclear fusion. So I think this is not a very new topic to you. You might have studied in your earlier secondary courses, but we will be dealing with some important equations here and have an idea how these might have helped forming the elements. Okay, here I will underline that nuclear fission is the splitting of a heavy nucleus into two lighter ones. Right? Fission, heavy into light. Okay, this is the basic definition. And was discovered by you have the scientists there, and you can see that the reaction U-235 being bombarded by a neutron, fast-moving neutron, is giving you the barium here, okay, and the krypton here, plus some again these fast-moving neutrons are there. These are the fast neutrons there. So you can see that this is a heavy nuclei, because it is having a very high atomic weight, and these are all the light nucleides. Okay, light nucleides. So by nucleides, we also mean that it's an atom, and uranium has been converted into barium and krypton. Barium is having 56 atomic number, krypton is having a 36 atomic number, and this was first detected in a krypton 92 fission product. In a typical nuclear fission, in a typical nuclear fission reaction, the neutron released, here it is, the neutron released by each dividing nucleus. Okay. When these neutrons collide, they induce fission. Fission breakup, okay, in other neighboring nuclei. A self-sustaining series of nuclear fission reacts known as the nuclear chain reaction. And this figure I'm just going to show you downwards. For example, the fission of U-35 releases 2 to 3 neutrons per fission unit. This is what is mentioned there. If you absorb by other 235 nuclei, these nucleons induce additional fission units. So further such things keep on moving, and the rate of the fission reaction increases geometrically. What does it mean by geometrically? It means that it spreads over a wide area. So it spreads over a wide area. So if not controlled, it results in some catastrophe, that is nuclear bomb. So each series eventually is called a generation. Experimentally, it is found that some minimum mass of fissile isotope, a fissile is verbal form of the fission, is required to sustain a nuclear chain reaction. If the mass is too low, mass means weight. Okay, you must know it is. This is the mass here. 235 is the mass. Is too low. Too many neutrons are able to escape without being captured. What is the escape? This is the escape. This is the escape. Without being captured and induce the fission reaction. Captured means, what is meant by the captured? See, this neutron is there, so it is, we are bombarding this neutron into the uranium. It has to go inside with some high energy and split to give these two things. Okay, but this process of giving into this is called as the capture. This process is called as the capture and inducing fission reaction. The minimum mass capable of separating sustained fission reaction is called as the critical mass. This is an important point. ஏதாவது ஒரு குறிப்பிட்ட ரியாக்ஷன் ஸ்டார்ட் பண்ணோம்னா ஒரு மினிமம் எனர்ஜி தேவைப்படுது இல்லையா, அதே மாதிரி நியூக்ளியர் ரியாக்ஷனுக்கு ஒரு குறிப்பிட்ட மாஸ் தேவைப்படுது. அந்த மாஸ் வரல அப்படின்னா அந்த ரியாக்ஷனே ப்ரொசீட் ஆகாது. because it has to sustain it. Okay. So this amount depends on the purity of the material and the shape of the mass, which corresponds to the amount of surface area available. Surface area na the area when you have a closed ordered cloth, its area is very small. When you open this, the surface area increases. Same thing is there with the lungs. Lungs inside the body, we have got very closed vacuoles. Now when you can open the lungs, it can spread to over a wide area. So surface area means, you increase the surface area, the neutrons can be absorbed more. So they cannot escape when you have greater surface area. If the mass of the fissile lattice is greater than the greatest of then the right conditions, the resulting superposition can release energy explosively. If the mass cannot be controlled, it can result in explosion. So that is what I was telling you about the atomic bomb. Okay, you need to have certain controllers to stop the chain reaction. The enormous energy released from the nuclear chain reactions is responsible for the massive destruction caused by the detonation of nuclear weapons such as fission bombs, but it forms the basis of the nuclear power industry. So even if it is controlled, then it's well and good. The energy can be used up for electricity and so many other industries. If it is not controlled, it becomes a bomb. Okay, so here in the fission, it is clear. Remember, fission is breaking. Okay, but in the nuclear fusion, in which two light nuclei combine to produce a heavier nuclei. What is a light nuclei? By light nuclei, I will take up a proton or hydrogen. I am taking two proton and just trying to get a heavy atom. So here it will be deuterium. So again, I am trying to put one more light nuclei, and I can get He3 to an isotope of helium. Okay, so you can see that this 1 is going to increase to 2 and is going to increase to 3. So lighter elements are fused into heavier elements. Okay, so likewise you see the previous reactions. Two light atoms can just fuse it. You know the meaning of fuse. The literal meaning of fuse is if you juxtapose, if you merge these two things, it's called as the fuse. The fuse which we have in our house in the electrical switch is also the same, is having the same meaning. What happens is when you have one is the phase, the other one is the neutral. Phase we always indicate by plus, in which the electricity moves, and neutral we always represent by minus. So electrons flow from phase to neutral. Okay, so as long as there is some resistance, you will get some light there. Okay. But what happens is if there is some no resistance there, this all the phase merges with this. Okay, the minus and the plus and minus charge merge with this. So you say that it is fused. So as a result of this fuse, a lot of heat is generated, and the fuse blows off. Fuse poetry, obviously, that is what you just say. And the fuse is blown off. So the same thing is there. You have the fusion. You bring two objects, just have enough surface area, have enough pressure and temperature, join them together, you call it as a fusion. Same thing is there with the nuclear reaction also. And then there is the transmutation. What is this transmutation? The transmutation is, you see, this proton is being converted into helium. So hydrogen to helium, transmutation is there. This you are getting transforming hydrogen into helium and helium into some carbon, carbon into nitrogen, nitrogen into oxygen. As long as you supply energy, it keeps on moving. And you can see that positive charge on both the nucleus in a large electrostatic barrier to fusion. Positive, இதிலும் positive charge இருக்கு, இதிலும் proton positive charge இருக்குல்ல, அது electronic repulsion இருக்கும் அப்படின்னு சொல்ல வராங்க. Okay, but the barrier na boundary, that is the barricade, barrier, boundary, everything the same thing. Two positive charges will not merge, will not fuse. Okay, the barrier can't be overcome if both the particles have sufficient kinetic energy to overcome the electronic expulsion. இப்படி ஜாயின் பண்ணும்போது ரிப்பல்ஷன் இருக்கு இல்லையா, அந்த ரிப்பல்ஷன் ஓவர்கம் ரிப்பல்ஷன் ஆயிடுச்சுன்னா வெளியே போயிடும். ரிப்பல்ஷன் ஆகக்கூடாது. அதனால என்ன பண்ணணும்னா கைனடிக் எனர்ஜி நிறைய கொடுக்கணும். கைனடிக் எனர்ஜினா ரெண்டுமே ரொம்ப ஃபாஸ்ட்டாக both the particles are moved very sufficient kinetic energy. So you require a different facility to make a slow particle into a fast moving particle so that it has got a very high kinetic energy and it overcomes the electron repulsion, allowing the two nucleus to approach close enough for a fusion reaction to occur. The principle is similar to adding heat to increase the rate of a chemical reaction. Remember, this is what is I have been telling you to differentiate a nuclear reaction from a chemical reaction. So here also it is telling that they are using the heat to bring about a change in the chemical reaction, as shown in the plot of nuclear bending energy per nucleon versus atomic number in figure. In the earlier figure, I just saw you show you that graph. The graph went something like this. So the nitrogen by proton ratio, it went up to ion 56, which let us know that there is a stability of certain elements. Beyond that limit, this radioactivity is increasing. I'll again tell you the graph or give you the notes separately. But for example, a typical fission reaction with two deuterium atoms combined to produce helium-3. Well, this is what I mentioned here. Is known as the deuterium fusion. Is known as the deuterium. Some people say it is deuterium fusion. This is the reaction there. Okay, so just let me show you the figures there. This is the chain reaction. Okay, this is the chain reaction. So you have the uranium 235. Now this is fission. This is fission. I have just given the definition first. The fission you are using 235, and this is the neutron. This neutron we call it as the fast moving neutron, or it is having more kinetic energy. Remember that kinetic energy, this kinetic energy is used to overcome the electrostatic repulsion of both the two protons. Because of the electrostatic repulsion, they will never join. But what you have to do, you have to put a sufficient kinetic energy to overcome this electrostatic repulsion. Okay, so you put a fast moving neutron into this. It goes inside. It is absorbed because it is having a large surface area. It splits into two, krypton and barium. So atom 1 and atom 2, two different elements are formed here. Okay. Now these two different elements again release sufficient energy for these two are again the neutrons. The neutron which you put here is being released as two neutrons here. Okay, because this mass is balanced. Okay, where you get two neutrons from this one you get one neutron, from this one you get neutron. Again, this is used to bombard the next U-235. This U-235 and this U-235 are the same, but in a different location. Okay, now this gives rise to xenon, strontium, cesium, and rubidium. So you can get to 4 elements. So this is called the second generation of the elements. Again, every atom is releasing one neutron and as its end product, and these neutron are again kinetic in nature. That meaning that they are having high energy, and they again bombard with the next atoms of the same uranium here. Okay, same uranium here, and in the end they are giving krypton, barium, cesium, rubidium, again krypton and barium, plus a lot of fission kinetic neutrons. Fission kinetic neutrons. So you can control these neutrons. Control these neutrons using graphite rods. Graphite rods. So if you do so, then you are using it in a nuclear industry. Remember, this energy is so huge that the amount of energy you can use it for powering electricity. So I remember one data there. I'm just going to tell you 1 kilogram of uranium. Okay, 1 kilogram of uranium, which is available in India in plenty in Mozosit sands of Bihar. Okay, it is used to put into fission. It releases so much of energy that a 100-watt bulb, okay, can be used to burn. 100-watt bulb can be burned, can be used for 1,000 continuous years. Look at the amount of energy that is there. ஒரு கிலோகிராம் யுரேனியம் எடுத்து ஃபிஷனில் போட்டிங்கன்னா 100 வாட் பல்பு 1000 வருஷம் கண்டினியூஸாக நீங்கள் எரிக்கலாம். ஓகே, so this is so much amount of heat is, so much amount of energy is there. Okay, but what we do is we are using it, most of the countries for political gains are using it for the bombings, you know. Like for example, in one of the nuclear reaction recently, 6 kg of uranium was wasted for testing a nuclear bomb. It doesn't help. It actually is a sadistic approach towards the developed nations. Okay, and in another reaction, a deuterium atom and tritium atom fused to, this is that one was fission and this one is fusion. Example is the graphics that is shown there. So you can see that this is deuterium, this is tritium. Okay, deuterium is here and tritium is here. These two join together to give a helium atom. Okay, so this is called as the fusion. It's called as the fusion, and it releases a lot of energy. And this process is what is taking place in the sun. Taking place in the sun. Nuclear fusion reaction, lighter nuclei combine to produce a heavier nucleus, as shown. Fusion of tritium and deuterium to give helium, and a neutron releases enormous amount of energy. In principle, the nuclear fission can produce much energy than fission, but very high kinetic energy is required to overcome the electrostatic repulsion. This is a very important thing you need to mention. Okay, so now let us move to the next part of the slide there, where the origin of this energy. The temperature comparable to that of the sun, I mean the interior of the sun, is approximately about 1.5 into 10 power 7 kg during a reaction. Okay, currently the only method available to such a temperature is detonation of fission bomb. இந்த அளவுக்கு டெம்பரேச்சர் வரணும் அப்படின்னா fission bomb ஒரு detonator explode பண்ணும். For example, the so-called hydrogen bomb or H bomb is actually a deuterium-tritium bomb. There is a fusion that is taking place, okay, which uses nuclear fission reaction to create the heavy temperature. Deuterium hydrogen bomb. Hydrogen bomb is fusion. Hydrogen bomb is fusion. Yes. So it is wrong given there. But this is the source. ஒரு எனர்ஜி வேணும், குறிப்பிட்ட எனர்ஜி வேணும். அதுக்கு என்ன பண்ணுறாங்கன்னா ஃபிஷன் எனர்ஜி எடுத்து ஃபியூஷனை கொண்டாடுறாங்க. ஃபிஷன் எனர்ஜி எடுத்தாக்கா உங்களுக்கு ஹை டெம்பரேச்சர் வருது. ஹை டெம்பரேச்சர் வந்தால் தான் ஃபியூஷன் நடக்கும். Only if you have high temperature, you will get the fusion of solid lithium to deuterite, okay, which releases neutrons, and then the next tritium. The deuterium-tritium reaction releases energy explosively, and the corresponding equation that is given there helps you calculate the amount of energy released. E equal to mc square, where E equal to energy and m is the mass and c is the velocity of light. So I am not working out the equation. So this is just to mention that we use this equation to account for the energy that is there. Okay. So again, I am summing up. Fission is the splitting of the nucleus. So I am summing up there. Is the splitting of that free neutrons and neutron nuclei. Fission is splitting of a nucleus that releases free energy and neutron nuclei. The fission of heavy elements is highly exothermic, means now it releases energy. Exothermic means releases energy. About, what is the energy? By about 200 million electron volts. Huge energy. You must remember certain numbers. நிறைய energy வருது அப்படின்னா எவ்வளோ energy? That is not there. You have to use the numbers to indicate the quantity. Okay. and compared to the burning of coals, which gives only few electron volts. Coal burn பண்ணா உங்களுக்கு few தான் இருக்குது. இங்கே billion electron volt. The amount of energy released during nuclear fission is millions of times more efficient per mass than the coal considering 2.1% of the nucleus current energy. So the nucleus that comes out is called as the daughter nuclei. Yes, sun nucleus சொல்றதில்ல, sun nucleus சொல்றதில்லைனா daughter nuclei further it breaks into some other nucleus. Okay, and the particles such as neutrons are released into as a result of this reaction. The particle release can interact with other radioactive materials, which in turn will release daughter nucleus and more particles. So this unique feature of nuclear fission reaction is that they can be harnessed and used in the chain reactions. This chain reaction is the basis of nuclear weapons. One of the well-known elements used in the nuclear fission is U-235, which gets converted into krypton 92 and barium 141. You have to write this equation. You have to write this equation to explain the nuclear fission reaction. Okay, so don't go into the more details there. Just read it out. Nuclear fission is splitting nucleus on the atom into nuclei of higher atoms, accompanied by release of energy brought down by neutron bombardment. Again, the same thing is said. I'm summing up the fusion there. Fission is joining of the two nuclei to form a heavier nuclei. The reaction is followed either by a release of absorption energy, fission of nuclei mass with lower mass than energy releases energy, while fission of nuclear heavy than energy absorbs energy. So this is it is said that lighter nuclei releases energy higher than iron. Iron is some kind of a threshold. It's a kind of a border. Okay, if something is having higher energy than the iron nuclei, then it absorbs energy. If it is not, it releases energy. That is being said. So you don't bother much about that. This phenomena is known as ion peak and is shown in a graph. Shown by a graph, in the previous slides you can see about stability of the nucleides. Stability of the nucleides is shown. The power of energy of a fusion reaction is what derives the energy that is released from the sun. How much essential? In the nuclear reaction illana life கிடையாது. There is no life if there is no star, and lot of stars in the universe. The star is also a sun. Our sun is also a star. Nuclear fission is also applied in nuclear weapons, especially hydrogen bomb. Nuclear fission is energy supplying process that occurs extremely high temperatures like in stars such as the sun, where the smaller nuclei join to make larger nucleus. The process gives great amount of heat and radiation. When uncooled, this process can provide almost unlimited surface area basis of the hydrogen bond. Since the most commonly used hydrogen is fused, it is called as the hydrogen bond. The combination of deuterium to form helium atoms is given like this. This equation you have to remember. This is very important. What is it? Proton plus proton or deuterium plus deuterium giving you helium atom plus fast moving energy. This is called as the kinetic neutron. So here is that this deuterium and this tritium, they combine to give helium atom there, and that is that. So in fact they mix up. This is the intermediate, and this is the product, plus a huge amount of energy. This energy is equal to mc square. Depending on the mass, the energy multiplied by that, and again you have this kinetic neutron. This is the kinetic neutron there. Okay, so I think we have got an idea about the kinetics of the fast moving reaction. Two elements join together, you call it as a fusion. Elements simply break up, you call it as a fission. You have to write some of the equations there. So that is all about the nuclear fission and fission reaction. Let's stop with here and see you next time for the next subject. Thank you.